Today we are going to see an interesting, important, most expected questions from solution chapter. Yes, come on, let us go and check each and every important questions expected from board. First and foremost, state the main advantage of molality over molarity as the unit concentration. Generally, molality is more accurate than molarity. Why? They may ask give reason type question also. Always they will have that eye on this topic, molarity, normality. That point, definitely you may get one assertion reason question or give reason type question or state like such kind of question you may get it. Okay, now let us go and see the answer. Molality and molarity. See, molality, it is more accurate than molarity. Why molality is more accurate? You know the meaning of molality? Number of moles of solute dissolved in 1 kg of the solvent. Mass of the solvent in 1 kg they mention. So this is mass. They are talking about that mass. But here molarity means number of moles of solute dissolved in volume of the solution in 1 liter. So this is volume of the solution in liter. So here we are talking about the temperature. As the temperature increases, volume of the solution also will be increasing. But whereas here mass is there, no, in the temperature increases means mass does not increase, mass will be same. So that is what molarity depends on the temperature of the solution, whereas molality does not depend on the temperature. So definitely you will get accurate result. That is what they mention. Main advantage of molality over molarity as the unit concentration, because molality it is more accurate because it does not depend on temperature, whereas molarity it depends on temperature. Why? Because as the temperature increases, volume of the solution also will be increasing. Hope you got a better idea about this question. Okay, come on, check some other question. Now the next question, find the solubility of nitrogen in liter of water at 293 Kelvin. Given that the partial pressure of nitrogen is 0.987 bar. KH for nitrogen at 293 Kelvin is 76.48 kilobar. Now, as you see the question only, you can make out this question is related to that Henry's law. How can you mention it is related to Henry's law? They have mentioned partial pressure of nitrogen, KH value. What is it Henry's law mentions? Mole fraction of a gas in liquid is directly proportional to the partial pressure of the gas above the solution. Yes, so that means partial pressure of nitrogen is equal to Kh. It's a Henry's constant into chi of nitrogen. That's what they mentioned. Find out the solubility of nitrogen in water. Yes. Now let us see the values, then we can apply. Okay, partial pressure of nitrogen, how much it is? 0.987 bar, isn't it? Okay, now KH value, they themselves have given what it is, 76.48 kilobar. Please note the point here, bar, here kilobar. That means we have to convert that into bar when we are applying into that formula. Okay, now so we have to find out what it is, mole fraction of nitrogen. So mole fraction of nitrogen in the sense chi of nitrogen. So what do you mean by mole fraction? Number of moles of component A divided by total number of components A and B, isn't it? So number of moles of component A, what it is? Number of moles of component A, we can take it nitrogen, divided by total number of moles of component A and B. Nitrogen in water, no? So N of nitrogen plus N of water. Okay, N of nitrogen negligible. Why it is negligible? We can neglect this. Why? Because very small extent which is dissolved. So we can neglect. Neglecting. Okay. And we have to find out this, of course. Now, number of moles of water, how much? Given mass by molecular mass, no, number of moles of water. So, given mass, how much? 1000 divided by molecular mass of water, 18. How much? 56, sorry, 55.56 moles, right? So, okay, we can apply this value here. Okay, now here what it is? Partial pressure of nitrogen 0.987 equal to KH value what it is 76.48 into 10 to the power of 3. Why did I put it 10 to the power of 3? Because kilobar, that's what I just mentioned here. Into what it is? N of number of moles of nitrogen. Number of moles of nitrogen divided by this is what neglected point. So this we can keep it here. We can keep what it is 55.56. Why did I mention 55.56? Number of moles of water. That's what I just mentioned. Okay, now we have to find out this. Okay, let us bring it this side. Number of moles of water is equal to, here what it is 0. Let it go this side 0.987 into 55.56 divided by 76.48 into 10 to the power of 3. Now, you have to calculate this. When you are calculating, you will get 7.169 into 10 to the power of minus 4 mole you will get it. Why? Because it is number of moles, no? So, here you can make it in another way 0.7169 millimole. Millimole. Why I mentioned millimole? It is minus 4, no? So 0.7169 I just mentioned. Hope you got a clear idea about this. See, whenever you see the question, as you see the value, you will come to know which is related to that law. From that you can make out. Now in this Henry's law related KH value they have given and partial pressure value they have given. So when you are writing that formula related to that law, you will get idea which one you have to find out. From that you will come to know the answer. Hope you understand this question. Okay, come on, let us go and see another question. Now the next question. Calculate the mass percentage of aspirin C9H8O4 in acetonitrile CH3CN when 6.5 gram of aspirin C9H8O4 is dissolved in 450 gram of acetonitrile. Now you have to find out the mass percentage of aspirin. What is the formula for mass percentage of aspirin? Mass percentage of solute? Mass percentage of solute equal to mass of solute. Mass of solute divided by mass of solution, total mass of solution. Mass of solution into 100, right? Okay, now mass of aspirin. Mass of aspirin. So this is what it is, C9H8O4 equal to how much it is? 6.5 gram. That's what they mentioned. 6.5 gram of aspirin which is dissolved in what it is, acetonitrile. So mass of acetonitrile, mass of CH3CN acetonitrile, that is methyl cyanide. How much it is? 450 gram. So total mass of that solution, total mass of the solution equal to, so 450 plus 6.5 gram. So together 456.5 gram. Okay, now mass percentage of aspirin. This is how much it is? 6.5 divided by 4, 56.5 into 100. That is what the formula it has mentioned. Okay, now what is the answer? You will get it 1.424 percentage of the mass percentage of what it is, aspirin. Hope you got a clear idea about this point. Okay, now let us see another question. Now, another important question. Antifreeze is a 35 percentage of solution of ethylene glycol in water. What volume of ethylene glycol added per liter of water in order to obtain an antifreeze mixture? Okay, now as you see the question only, you will ask that question, what do you mean by antifreeze mixture? Yes, come to this point. A substance which is added to the solvent to lowering its freezing point. Yes, come to this point. Example, ethylene glycol is used in car radiators to lower the freezing point of water. I hope now you got an idea ethylene glycol for what purpose we are using and where we are using. I hope you got an idea. Okay, now let us go and identify how to solve this problem. Let us see that formula, volume percentage. Volume percentage of ethylene glycol. So we can mention ethylene glycol, volume of ethylene glycol. Volume of ethylene glycol divided by volume of the solution. Volume of the solution. Because solvent plus solute, no, into 100 mass percentage like volume percentage. Okay, now let us see, apply the value. What are the percentage they have given here? 35 percentage of ethylene glycol. Volume we don't know, that only we have to find out. And volume of the solution. Volume of the solution means solvent plus solute. Solvent here what it is? Water only they mention per liter of water in order to add volume. We don't know that volume, so we just put it this ethylene glycol volume we don't know into 100. Yes, we applied the value. Okay, now we can calculate this. So here 35 into 1000 plus V equal to 100 V. So this one and this one, let us calculate it. Okay, now what is the value? You will get it 35,000 into 35 V is equal to 100 V. V means what it is? Volume, right? Okay, now 35,000 equal to 100 V minus 35 V. We just bring it over here. So you will get what it is? 65, right? Okay, so 35,000 equal to 65. 65 V. 65 V. Therefore, volume is equal to what it is? 35,000 divided by 65. So what is the answer? You will get it. Come on, let us calculate it. Here 538.5. Okay, volume only. No, we can write centimeter cube. So how much volume required here? It is 538.5 centimeter cube. Hope you got a better idea how to solve such kind of question, and it is very important question. And even antifreeze, they may ask the question, what do you mean by antifreeze question? And ethylene glycol formula CH2OH, single bond CH2OH. In alcohol, you might have learnt about that dihydric alcohol. Hope you got a better idea about this question, and it's very important. Generally, all NCRT questions are important. Okay, let us take this question. Sample of drinking water was found to be severely contaminated with chloroform. suppose this has to be a carcinogen. The level of contamination was 15 ppm, that is parts per million by mass. Now, first one, express this in percent by mass. The second point, determine the molality of chloroform in water sample. Okay, 15 ppm by mass means what they are mentioning, 15 gram of chloroform in 10 to the power of 6 gram of solution, right? That means percent by mass, percent by mass equal to mass of chloroform, mass of chloroform divided by total mass into 100. This is what the formula. Okay, now the first one. So here mass 15 divided by 10 to the power of 6 into 100. Right? Now mass, how much you will get it? 1.5 into 10 to the power of minus 3. What it is? Percentage. Yes, we can take this one. Okay, now the second one, molality of chloroform in sample. Molality formula, molality, right? So molality equal to number of moles of chloroform CHCl3 divided by mass of water into 1000, right? This is the formula. Now we have to find out what it is, number of moles of chloroform. So number of moles, how to identify number of moles, given mass by molecular mass, right? So number of moles of chloroform CHCl3. So number of moles given mass by molecular mass, given mass by molecular mass. Okay, given mass how much? Here 15 gram, right? They mentioned here. Here 15 grams. So 15 divided by molecular mass of chloroform. How much? 119.5. So you will get 0.1255 moles. This is moles. Moles because small m, that is meant for molality, right? Moles only you can write. Okay, now you can apply the value here. Mass of water, we have to find out now. Mass of water, right? Mass of water we have to find out now. So this is 10 to the power of 6 minus 15, right? It. Okay, mass of water, that means here we can take 10 to the power of 6 only because approximately we can take. Now we can apply the value as I mentioned here, 0.1255 divided by 10 to the power of 6 into 1000, right? So you will get 1.255 into 10 to the power of minus 4 molality, small m, molality of chloroform in water sample. I hope you got an idea how to solve this sum. First and foremost, you have to express in percent by mass. This is that answer. And second one, this is the first answer. And this is the second answer. You have to bring it. Hence, this is the value like you have to bring and write it. Hope you got a better idea about this sum. Okay, now let us go another sum. The next question, what volume of 0.1 m of HCl is required to react completely with 1.0 gram of an equimolar mixture of Na2CO3 and NaHCO3? Actually, this is very interesting and simple question also. Let us watch this. Okay, now they have given very clearly it is equimolar mixture. Let the mass of sodium carbonate present in the mixture. Let the mass of sodium carbonate Na2CO3 present in the mixture and the mixture how much it is, just we can take it as a x. The same way mass of NaHCO3 sodium bicarbonate, mass of sodium bicarbonate, how much we can take it, equimolar mixture, no? So 1 minus x gram we can mention, because everything mass only, no? So mass means unit, it is very important. Okay, now next one, molecular mass of sodium carbonate. Molecular mass of sodium carbonate, how much it is, 106, you know very well, this is gram per mole. The same way, so molecular mass of sodium bicarbonate CO3, this is 84 gram per mole. So now you have to identify number of moles of Na2CO3. So you can write it given mass by molecular mass. No, so given mass what it is, x gram divided by molecular mass 106. The same way number of moles of NaHCO3. This is 1 minus x by 84. Okay, now let us calculate in this way. X by 106 is equal to 1 minus x by 84. Let us go for the cross multiplication, because 1:1 ratio equimolar mixture they mention, no. So cross multiplication if we go means here 84x 84x equal to 106 into 1 minus x, isn't it? Okay, now 84x equal to 106x minus 106. 106 into 106x, okay. 106 minus 106x. Okay, now let us come this side. Here 106 equal to here 106x plus 84x. So here altogether 190x equal to 106. Therefore x equal to 106 divided by 190. You will get the answer 0.5579 grams, because they mentioned x only, no, so that is given mass of sodium carbonate. Now let us check that number of moles of sodium carbonate. We can apply this value, given mass how much it is, yes, I just mentioned in this different color. So 0.5579 divided by 106. Why do we apply here, you know, x, that is what purposely. Now another point here, 1 minus 0.5579 divided by, why, because 1 minus, here what it is, 1 minus x value, so this is 84. Now what is that answer you are getting here, that is number of moles of respective formulas, right? Okay, now let us go and identify what is the answer you are getting here. So this answer you will get it, can you calculate this? You will get the answer here 0.005263, right? So that is number of moles of that sodium carbonate. Now let us identify this answer. Here this also the same thing, you will get it 0.005263 moles. Okay, now let us calculate the volume of that 0.1 m of HCl required to react. Okay, now let us see this equation. Na2CO3 reacts with HCl, it gives NaCl plus H2O plus CO2. Balance this equation here also 2, Na2Cl. Na2CO3, so it's Cl, yeah, you got it. Okay, now here how many moles actually here 0.005263 moles of Na2CO3 requires how many moles here? 2 moles of HCl required, right? 2 moles of HCl required. So 2 into 0.005263, right? Okay, now the same way sodium bicarbonate NaHCO3 plus what it is HCl. It gives NaCl plus H2O plus CO2. Let it balance. Yes, it's already balanced. So the same idea 0.005263 moles of sodium bicarbonate requires how many moles of HCl? 1 mole of HCl. Here 2 moles of HCl, here 1 mole of HCl. So altogether it is actually 3 moles of HCl required. That is actually what it is, equimolar mixture. So that means here 3 into 0.005263. As I mentioned here 3, you know how do we get this 3? 2 HCl plus 1 HCl. So altogether 3. Why? 3 moles of HCl required to complete the reaction with 1 gram of equimolar mixture of sodium carbonate and sodium bicarbonate. Now we have to check the volume. See here 0.1 m they have given the molarity. Now we have to find out the volume. Okay, let us write this 1 gram of 1 gram of mixture. 1 gram of mixture, what it is? Sodium carbonate and sodium bicarbonate requires how much HCl required? 3 moles of HCl required. So that means 3 into 0.005263. This is number of moles of mixture, right? We have to find out the volume of solution, how much volume requires. So we equal to number of moles of mixture divided by molarity into 1000, right? Now 3 into 0.005263, same value only we got it now both. Then what is the molarity? 0.1 into 1000. What is the answer you are getting here? Now volume only now we are finding, that means centimeter cube, or we have to write it that unit. That is what I just mentioned here, 157.9 centimeter cube. So this is a simple question only, and we are getting interesting answers all that, and all those steps are really, it will be easy to understand. I hope you got a better idea to this question, and this is very important question also. Now how much of volume required? What volume required means here 0.1 m of HCl required. This is 157.9 centimeter cube which is required to react completely with 1 gram of an equimolar mixture of sodium carbonate and sodium bicarbonate. Hence, you have to bring the answer. Hope you got a clear idea about all the sums which is related to the board. Thanks for your great support. Please subscribe this channel, hit the bell icon so that you will get all the notification. Thanks for watching.